In this section, we're now going to take everything that we've learned about the addition of vector components and we're going to apply it to real life situations, boat in the current types of problems, plane in the wind types of problems. So we're going to do the same thing that we've done before that I showed you in the last video. And if you understand how to do that, you can turn this video off and you don't even need to watch it. But if you would like to see me work out another problem like the one we worked in video number 5, then keep watching and I'll work through example 3.6, the first part of that for you. Now this says that the pilot is steering the plane at 125 miles per hour at an angle of 30 degrees. So just like we did before, we want to go ahead and plot that on a coordinate so that we can see about where our final answer should end up at. So at 30 degrees, I'm going to be looking at something about like this, like that. And then the wind is blowing at 20 miles per hour at 225 degrees. Okay, so 225 degrees is in a southwesterly direction, and this is 20 degrees, so this is about a fifth the length of what this would be. So at 225 degrees, I'm going to be going down, sort of like that. Again, this doesn't have to be exact. We're just looking for something so that we know that our final answer is in the right ballpark. So the resultant vector is going to look about like this, okay? It would make sense that if she's going this way and the wind's blowing, that she's going to get pushed this direction and it's going to slow her down some. All right, so we're going to first need to calculate the x and the y components of both the plane and the wind. And so you remember that the x component requires the cosine. So I'm going to take 125 miles per hour times the cosine of 30 degrees. And the y component is going to be 125 miles per hour times the sine of 30 degrees. Okay? I need to do the same thing for the wind. The wind is going to be 20 miles per hour times the cosine of 225 degrees. And over here, I'm going to have 20 miles per hour times the sine of 225 degrees. Okay, so when you take your calculator and you crunch all those numbers out, you end up with 108 miles per hour here. 3 significant figures because both of these do. And this will be 62.5 miles per hour. Okay, both of those should be positive. That makes sense because this initial vector was up in the first quadrant. The second set for the wind, this gives me a negative 14.1 miles per hour. Again, I have 3 significant figures because I had 3 in both of these. And then I have a negative 14.1 miles per hour here. And so if I look at this, the direction of this vector, if that started here at the origin, it would be down in the third quadrant, so the x component should be negative and the y component should be negative. So both of these answers make sense as well. Okay, so now I'm going to add these two guys together, and remember we're going to use now the rules for addition and subtraction. So my final significant figure is going to be in the units or the ones place. So this is going to be 94 miles per hour, and this one is, but this will have an answer in the tenths place. This is going to be 48.4 miles per hour. Okay, now that I have the x and y components, I can calculate the magnitude and the final angle for the direction. So the final velocity is going to be the square root of 94 miles per hour, the quantity squared, plus 48.4 miles per hour of that quantity squared. Take the square root of that whole thing. And when you crunch those numbers, you should end up with 106 miles per hour. Again, significant figures. This is in the tenths place, but this is in the units or ones place. And so your answer is going to be in the units or ones place as well. Okay, so then in order to calculate And as I told you before, this one is larger than both of those, which makes sense since we're using the Pythagorean theorem. Then if I want to find the angle, I'm going to take the inverse tangent of the y component, which is 48.4 miles per hour, over the x component, which is 94 miles per hour. And when I do that, I end up with 27 degrees. Now, do I have to do anything to that angle? Remember, sometimes we have to add 180 or we have to add 360. Do I have to do anything to this one? Well, the x component was positive, the y component was positive, and so what that means is that I'm going to be in the first quadrant, and that's what my initial picture showed me. So no, I don't have to do anything to this angle to put it in the right form for physics. So the final answer for my velocity is going to be 106 miles per hour at 27 degrees. Okay, so again, this problem is similar to the one that we worked back in video number 5. They're all done about the same way. If you have questions, again, please make sure you contact me and ask for help, because we are going to be using this very same system in the next several modules to be calculating all sorts of fun things. So you want to make sure you understand this really well.